Welcome to Vertica Girl. What do you see on the screen? There are 3 nodes, each holding a slice of your data. But a cluster isn't 3 separate machines. It has to act as one single database. So how do the nodes know about each other? How does node 1 know about node 2? And how does node 1 know about node 3? Whether they are alive or whether they are in failed status. So they need a control layer, and in Vertica that layer is called spread. On their own, these nodes are just islands, basically disconnected from each other. Node 1 has segment A1, node 2 has segment A2, and node 3 has segment A3. But none of them can see others. No coordination. If node 2 died, node 1 and node 3 wouldn't even know. That's the gap the spread fills. So spread is basically Vertica's control layer, a messaging bus that connects every node in the cluster. Think of it as cluster's nervous system. Once spread is running, the nodes stop being an island and they are wired together and are constantly talking to each other. But here is the important part. What travels on spread is control messages, not your data. Each node sends small steady signals like I am alive, here is my state, here is what I am working on, and so on. So spread carries those messages, so every node shares one consistent view of cluster, like who is up, who is down, who is doing what. Your actual data, basically the big transfers, moves node to node on a separate channel. Spread stays lightweight because its only job is coordination. So why does this matter? Because spread is how Vertica notices a failure. The instant it happens, triggers K-safety to failover and keeps every node up to date. It's a quiet control layer that turns a pile of servers into a coordinated database. So we have seen that spread is the control layer, basically the bus carrying coordination between the nodes. But what actually is spread and how does it run on your cluster? It's an open source messaging toolkit, a proven group communication system, and Vertica builds its control layer on top of it. So the reliable messaging that keeps your cluster in sync, and it runs as a daemon, a small background process on each node. Node 1, node 2, node 3. Everyone runs its own spread daemon. Together, those daemons form the messaging fabric. When a node needs to send a message or find out that another node has just dropped, the daemon is what sends and receives the signal across the spread bus. Two things make spread practically invisible to you. First, it starts automatically with the database. You don't launch it separately. When you spin up your Vertica database, the daemon comes up with it. Second, it's resilient to network faults. A brief hiccup or a dropped packet or a momentary partition or pause. Spread is built to absorb it, reforming the cluster membership and keeping the messages flowing so a glitch doesn't turn into an outage. So that's the spread under the hood. Basically an open source messaging toolkit running as a daemon on every node, starting automatically and shrugging off the network noise, the quiet reliable backbone of Vertica's cluster coordination. Next we go deeper, basically how those daemons actually detect a failed node, heartbeats, timeout, and the moment spread declares a node is dead. I have been saying that spread carries control messages and not your data. Now let's make that exact. because this one distinction is the whole key to understand what spread does and what it doesn't. This is the control layer. It runs over spread using UDP, which is fast, lightweight, and a connectionless protocol. And what flows here is small essential signals as mentioned earlier. Node state, who is up, who is down, who just joined, who just left, and so on. Query plans, coordinating which node does which part of the work. Commit messages, agreeing that a transaction is finished. This is the coordination bus that makes these three machines behave like one database. Now the data layer, the actual data, the query results moving between the nodes, the rows shuffled during join, the blocks copied during recovery, and so on. These all don't go over spread. It travels node to node over TCP, a separate, reliable, high throughput channel built for volume. Spread never touches your bulk data. So spread is the nervous system and not the bloodstream. The nervous system carries the signals, do this, do that, commit now, and so on. The bloodstream basically carries the volume. Spread carries control messages between the node daemons, but it doesn't do that over a single path. Spread actually runs two channels, each with a different job. Let me show you both. First, the main channel. This is the primary path for control messages. Every node's spread daemon uses it to exchange the actual coordination traffic, the node state, query coordination, commits, etc. directly with the other nodes. If spread has a highway for control messages, the main channel is the one. Second is the token channel, and it's basically a logical ring, a single token circulating around it node to node, from node 1 to node 2, node 2 to node 3, and back to node 1. So round and round, only one token always moving. That token is responsible for three things. First one is membership. As it circulates, the ring always knows exactly which nodes are present. If the token can't complete its loop, it means that a node has dropped out. Next is fault tolerance. That same mechanism is how spread detects a failure and reforms the ring around it. And third one is message ordering. Because the messages are tied to token strip around the ring, every node sees them in the same order. So one circulating token gives the whole cluster a single agreed view of reality. So that's the two channel design of spread. So the main channel moves the control messages, the token channel keeps everyone in agreement who is in cluster, how failures get handled, and what order things happened in. So two channels working together and a pile of separate nodes behave like one perfectly coordinated database. There is more to cover with regards to spread. Wait for part 2. I hope everyone got a clear picture. If you found it useful, please do like, share, subscribe, and hit that bell icon for regular updates. Thank you.